Welcome back. Today I want to look at solving simultaneous equations using the elimination method, but the equations that we want to use this time do not have a variable with a common coefficient. So by that what I mean, is we can look at these equations, two equations here. We have the coefficient of x in the first equation is 3, but in the second equation it's 2, so they're not equal. If we look at y, the coefficient in the first equation is minus 2, and in the second equation it's 3, so they're also not equal. So we don't have a matching pair of coefficients, so it's not so straightforward to easily eliminate either x or y. So these are our two equations. Again, I've gone ahead and labeled them. I've named both the first one as equation 1 and the second as equation 2. And I want to eliminate one of those variables. So what I've decided to do is to eliminate the y variable. Now the reason why I've chosen y is because the signs are already opposite. So remember, what we're looking to do is have matching coefficients, yes, but once they match we want to change them so that one's positive and the other's negative. In this case our y coordinates don't match, but at least one is positive and one is negative. So we're part way there. So that's why I'm deciding that I'm going to eliminate the y variable. And the first step to doing that is to make the coefficients match. So currently the second variable has a coefficient of 3. If I use that coefficient and multiply up the first equation by that, this first equation then, that minus 2 there, will be changed to minus 6. So what I'm going to do then in the next step is change this plus 3 to be plus 6, and then these will match. So I'm using the fact that these are different to make them the same. So I'm taking the coefficient from equation 2 and I'm going to use it to multiply equation 1. So 3 multiplied by 3 gives me 9. 3 multiplied by minus 2 is minus 6. And 3 multiplied by 6 is 18. Okay, so I've now got my minus 6 for my first equation. I need to also get a minus 6 for the second equation. And to do that, I'm going to multiply minus 2 by plus 3. Of course, remember, I can't just multiply the plus 3 by minus 2. I have to multiply everything by minus 2. So if I take the 2 by 2, I get 4. 2 by 3, I get 6. 2 by 4, I get 8. Okay, and I'm keeping the sign, so it's actually not minus 2 I'm multiplying by, but just the 2, because the minus is already in there. That's why I chose the y in the first place, remember? Okay, so I'll look at my two equations now. I have the same coefficient, and I have one is plus and one is minus. So I can use what we learned in the elimination method before. If I add them now, the y will be eliminated. So let's add them. 9x's and 4x's is 13x's. 6y's, take away 6y's, this will give me no y's. Y's will be eliminated. 18 and 8 is 26 on the other side of the equal sign. So don't forget your equal sign stays lined up here nicely the whole time. So 13x's is 26, so 1x will be 2. I have my first solution. I need to take that solution, plug it back into one of these equations till I figure out what y is. So let's go back to equation 1 with 2 instead of x. So here's my equation 1. I'm putting 2 in instead of x, so I'll have 3 2's. Take away 2 y's is 6. So 6 take away 2 y's is 6. If I subtract 6 from both sides, so take the 6 away from this side, take the 6 away from this side. Remember, I have to have something here. So if I have 6, take away 6, I have nothing. So minus 2 multiplied by y is nothing, so y itself must be nothing, 0. So here's my solution to 0. Is this the correct solution? Have a check in both equations. So checking in the first equation, putting 2 in for x and 0 in for y. So putting 2 in for x and 0 in for y, I'll have 3 2's is 6, take away 2 zeros is 0, 6 take away nothing is indeed 6. Now I also have to check in the second equation, putting in 2 and 0, yet again substituting. So 2 2's and 3 zeros, 2 2's is 4 and 0, and 4 and 0 does indeed give me 4. So the key to this solution, when we don't have any pairs of coefficients that match, we make them match by multiplying one equation by the coefficient of the other. So we multiply equation 1 and we multiply equation 2, and we switch the coefficients each time.